Right, there we are. We're going to look at how they make bow handles, or risers as they say. Height, this is an old TD4. We call it die casting. Die casting goes back a long way. It goes back nearly 1848 or so. It was primarily made for the printing industry, Heidelberg printing machines and things like that. They had to make the frames and they use die casting. So they started to look at bow handles, and what they make is they make a mold, and it's a magnesium low melting point alloy that goes into the mold, and the mold is reusable, and this is what comes out after that. And then you have a very, very good quality bow handle, very, very, very strong. So that's one type. Then you have, this was an old marksman. This again die casting as well. Okay, very, very high finish on it. So you can see the quality of the finish on these handles. And then you work then into what they have is what they have die casting again on this type, very, very light beginner's type bow. It's die casting. You move then on to what they call the CNC. So you have CNC on the CNC machine, that's a CNC handle. But they also do a forged handle as well. And they machine the forge, the shape of the handle is machined. And then you come in then into carbon fibre. Now, as I say, this is an old Carbofast one, goes back a long time. Win and Win now have really perfected the use of carbon risers. They've brought it to a new level. You have to give them credit for that. In Carbofast, our emphasis wasn't on bow handles, it was on mainly on the aerospace industry, and that's the road we took. So we didn't go into making handles, but I made a lot of handles for individuals, particularly in barebow shooting and things like that, which are very, very, very successful. So it's a very, very simple process. It's a mold, and how they make it is they have cut patterns in carbon fibre, mainly on a type of CNC machine. So it's very, very refined pieces of carbon, all set in a specific way that they don't have the misalignment of any of the fibres, and with the result, that handle will come out as straight as any machined handle. Again, are these handles straight? Of course they are straight, but it depends again on the quality control and how they work their quality control systems, and are the molds in perfect alignment and that sort of stuff. So if you put the quality in, you get the quality out. Basically, that's how it works out. So you have machine handles, CNC, forged handles, die casting handles. They all work quite well. So where did it come into, we say, do the CNC machine handles? That came about by young guys working in technical schools, and they had a look at the CNC machine, and with the result they said, well, okay, if we put a program in here, we can make a bow handle. Many young boys, young lads, apprentices and young girls made bow handles on CNC machines. So that meant then that the people who are investing, your bow company who are investing into dies for die casting, a die casting to make a bow handle, it would cost a lot of money. But to do a CNC machine system, that's a different ball game altogether. So the bow handle manufacturers, they had to come up with innovation to make a handle that was absolutely fantastic. Now, does that die casting, does the forge, does the CNC, does the carbon shoot any better? That has to be measured, and you can't measure that unless you do a scientific survey on whether they work or not. But you get a lot of hype from different bow manufacturers saying this, saying that, and the other. But the proof of the pudding is in the eating. If it's the handle is straight, what are you talking about being straight? Are the limbs straight? This is another thing. Is the tiller done properly on the bow? There's a lot of equations that have to be looked at in relation to bow handles, but they all shoot very, very, very well. So whether you can shoot that one better than the machine one, that's very debatable. I'll give you kind of a story. We had when I was working with Jack Crowson and Dutch Archery Specialists, and we got an agency for a company called Turtle Ship in Korea, and we brought those handles in, and we got bad press. They got a bit of bad press about it because the quality, not so much of the straightness, but the paint work on them wasn't as up to standard, you know. So what we're going to lose money out for bringing all these handles in, and you know people won't buy them. So we need to do something. So we got one of the top archers, and we got the best one, the one that was painted the best, and we got the best one, and we put a good set of limbs on, set it all up, got the guy to shoot it, and he shot very, very high scores. In fact, he won the competition that day in excess of 1280 with a handle that was supposed to be die cast and was supposed to be rubbish, but yet he was able to do it. So when you're looking at handles and things like, look at the amount of money you're going to spend on it, but you won't go far wrong. As I said before, in a lot of the talks I've given, Earl Hoyt designed that handle, and it hasn't changed. Almost the same. You take up, it is the same. The old TD4, same geometry. Doesn't change. Doesn't change. So whether that's better, or that's better, that's up to yourself. But I would be guided by your pocket, you know, and you can't buy scores. So that's how handles are made, bow handles are made, and give you an insight into it. So don't be fooled by the hype. Buy according to your pocket, good quality. How do you know that the handle is straight? There's no problem on that end of it. There's all sorts of gadgets you can use to see if your limbs are in line. You can use the bow square, no problem with that. You can use the biter gauges to have a look at your limbs to see if everything is in line and things like that. And then combined with that, then most of the bow handles, the companies are making a system on that where they can, you know, alter the limb slightly. So your bow will never be out of line. It'll always be in line. So you can work around all these things. Now, if a bow is in line, does it shoot any better than a bow that's not in line? Again, that has to be borne out by a scientific approach to it. So I hope that enlightens you into bow handles and how they're made and what happens with them. So thank you.